Hi, we are ElectroGtu Team. We created this team for participating in the design competition with Xsens Products. We are from Gebze Technical University. Our team has 3 members and 1 technical advisor. Our members are Sefa Kurt, Recep Sait Dülger and Yunus Emre Peker. All members are undergraduate students and all members' department is electronics engineering. Our technical advisor is Associate Professor Dr. Fuat Aliyev, who is working at Gebze Technical University. We built an autonomous robot car for this competition, but it is not a normal robot car. Firstly, it's a tracked vehicle. Secondly, and the most important thing is that you can control its direction with laser beam. In this video, we will talk about our vehicle and its technical features.
We designed electronic circuits and mechanical systems which belong to our vehicle. And of course, we created its algorithm and wrote its codes. Finally, we tested all subsystems and full system. Before we explain all subsystems detailed, I want to talk about how our vehicle works and which field it can be used. First of all, we designed this vehicle for the defense industry, but after some time, we noticed that we can use this vehicle for transportation. At the beginning of the project, we thought that mines can be found and defused by remotely controlled land vehicles. But if there is a jammer, you cannot control land vehicles. Because of this cause, we searched for another solution for controlling land vehicles. Finally, we decided that we can control with laser beam. Our vehicle detects laser beam, decides which direction it will go based on the location of the laser beam, sends the necessary signals to the DC motors and gives a warning if it detects a mine while in motion.
Let's take a detailed look at how our vehicle works. Firstly, we used the following items for our vehicle. For gimbal circuit, 3 servo motors, 1 MPU 6050 accelerometer, 1 Arduino Nano, 1 LM2596 voltage regulator, and 1 SD card module. For main circuit, we used 1 HCSR04 ultrasonic sensor, 1 Hall effect sensor, 1 buzzer, 5 LDRs, 1 L296N motor driver, 2 DC motors, 1 Arduino Nano, 1 LM2596 voltage regulator, 5 BC237 transistors and resistors, trim ports, etc. For power supply, we used a 3S lithium polymer battery. Thanks to a mirror, laser beam reflects in the LDRs. Since our vehicle is suitable for the terrain, this mirror always stays fixed on the vertical axis thanks to the gimbal mechanism. This gimbal mechanism consists of 3 axes. These are that yaw, roll and pitch axis. Normally, gimbal mechanisms are used brushless DC motors, so it can move at small angles. But because of brushless DC motors price, we couldn't use that. Instead of DC motors, we used servo motors. Of course, our mechanism cannot move clearly, because servo motors aren't suitable for gimbals. But it worked. The resistance of LDR from which the laser beam is reflected decreases and the transistor is switched on. The outputs of the transistors are connected to Arduino, and when the transistor is switched on, the interrupts function are started to work, and the motor control is provided. So you can move the vehicle left and right. Thanks to the ultrasonic sensor, the vehicle detects the object and it will slow down or stop. Thanks to the Hall effect sensor, vehicle detects mines and it gives buzzer warning and stops. If you want to use this whistle in the defense industry, you don't need to carry an extra laser source. You can control the whistle direction with the laser on the guns. If you want to use this whistle for transportation, you can do unmanned transport by simply placing a laser source. Thanks for watching our project's video.